Okay, so before the case let me talk about some a bit of new things here. So, and of course, on Tuesday we talk about vector product, and we can also call vector product as cross product. Now, for two vectors, then of course we have vector product or cross product, and but we have another product called scalar product or dot product. And of course you know the Chinese, and this is the Chinese, and so in dot products that we in English we say P dot Q, okay? And the scalar product of two vectors is scalar, and it is equal to P times Q times cosine theta. Okay? And for vector products, that the P cross Q is does not equal to Q cross P, but in dot product, P dot Q is equal to Q dot P. And I think you know these properties, right? And so for this of course for P and Q we have here, and then we have this is theta. So for these dot products we have different uses. The first, because we have this property. Now, and if we have a dot product of by itself, for example, P dot P, we will arrive in the square of the magnitude of P, right? The square of magnitude. Square of magnitude of P. Right? From here we can say we have some uses for this for the product. The first one is we determine how to determine the angle theta between two vectors in 3D. So let's say these two P and Q are in 3D, and we want to determine the angle theta between the two vectors. So, and because the definition is here, so we can simply write this one. I'm sorry. Because we have this, we can write this, right? You just put the terms around, and you move the terms up. We can move this here, and then you'll get this. And as I've said, if you want to get the magnitude of P, then P squared is equal to P dot P, and Q squared is equal to Q dot Q. So we can simply write it in this way. You may say this is quite long, but if you write it in the computer program, it will be quite logical to write this in computer program. Okay, in computer program. If you write, for example, if you calculate this in Excel, or if you write it in C# or Python, then it may be easy to write it in this way to determine the angle theta. The other way is the other use of this method is for projection of vector. Projection is and I think I've mentioned this in another on another page. projection of a vector on a given axis. And what does it mean? It means, for example, we have a vector P here. We have a vector P here. Now, suppose we have this. Suppose we have the sun here, and then there is a shadow here. So we are talking about this axis, and I think I marked it as axis OA. This is okay. And for example, we have a line here. So, and we can say we have P can be written as P can be written as P parallel and P perpendicular, right? We done this before. And this is right angle. And remember, P and OA are all in 3D, so you cannot. It is not easy to do it by we put it on XYZ. Okay, so suppose these are in 3D. So we have, and of course we have angle theta here. So we have the length of P parallel is equal to P cosine theta. I think it is clear. So, and so how do we get this? So we get this by recording. Recording is recording the definition of dot product. So P dot Q is equal to PQ cosine theta. So and P cosine theta is equal to P parallel, and this is equal to this one. And so we get P dot Q vector Q over magnitude of Q. Of course, you can use this to calculate this. Of course, it is okay to use this to calculate this. But if we write it in this way, and we move the terms around, we write it in this way, and you can see this one. The magnitude of Q vector is of course Q. So if division of Q vector by scalar Q is equal to a unit vector in the direction of OA. So, and we will use this on next Tuesday. And we come to it's okay. And we have learned vector product and we have learned scalar product. Next Tuesday we will use both of them together, and we will have something called mixed triple product. And the definition of mixed triple product is this one. And so is this mixed triple product, does it give us a scalar or does it give us a vector? Scalar vector. First of all, these two will give us a vector, right? This one will give us a vector, and then we have scalar product of this one and this one. So the answer is scalar. Okay. And if you want to draw this here, and so B cross C is here, and then we have B cross C is here, and then we have A there. And why are we doing this? Because this has a geometric significance. Geometry is this one. Significance EE. In vector products, the geometric significance of vector product is if we have B cross C, that what do we have? This is it gives us the area of parallelogram. Or to be strict, the magnitude of B cross C is the area of parallelogram. And how about mixed triple product? Mixed triple product will give us the volume of the constructed by A, B, and C. And you can see none of them are with 90 degrees. Okay, so if we have three vectors, then A, B, and C here, and they are not with 90 degrees, but we can still construct we can still get the volume from this shape. Okay, because this one is 90 degrees, and this one does not equal to 90 degrees. We can still get the volume of this shape by getting the three vectors here, and then we calculate this, and we can get the volume. Okay. And for your information, for your reference, that to calculate this, you calculate the determinant of this. Okay. And this is the new thing I want to introduce today.